In this tutorial, we will be discussing predicting products of precipitation reactions. The key to predicting precipitation reactions is understanding that only insoluble compounds form precipitates. In other words, if it forms a solid in the solution and it falls out, you will physically see something. It'll be a different color, it'll be kind of flaky, it'll see some kind of a solid being formed. In precipitation reactions, two solutions containing soluble compounds, meaning AQ, we talked about it in a previous tutorial, combine, and an insoluble, meaning it's going to be a solid, compound precipitates out. So as an example, let's take potassium iodide and we're going to mix it with lead 2 nitrate. Individually, the reactants are in two separate beakers, with the ions floating around within the beaker. Because of this plus sign, we're going to end up mixing them together. Here. So now we have all four of those ions floating around in the solution. What ends up happening is that the inside ions and the outside ions start to interact. And I say that because remember, this is a positive, negative here. So the positives and negatives find each other from the other reactants. So lead now mixes with iodine, and potassium now mixes with nitrate. Then you have to figure out whether or not that's going to be a soluble compound. There's a list of solubility rules which we'll discuss in a little bit. But if you're actually in the lab, you're going to see something happen. For instance, here lead iodide forms a solid in the solution. So we know that there is a solid happening. That's when we go back to our solubility chart and look at which one of the two actually formed a solid. If nothing ever happens, if they're all still floating and no solid is formed, you don't see a change, then no reaction has occurred. But here we see lead is insoluble, which means it gets a solid next to it, an S. Potassium nitrate is still in solution, it's soluble, so it still has the AQ. So let's go through these step by step. Here we have sodium carbonate mixing with copper chloride, copper 2 chloride. The outside ions come together and the inside ions come together. If it's written first in the compound on the left hand side, you need to make sure that it's written first in the compound in the products. That's because the first one over here is the positive, and the positive is always written first. So Na is now with Cl. Na is a +1, Cl is a -1. You crisscross it and it becomes 1 and 1. Whenever you put these ions together, make sure you figure out the charge and crisscross it. The inside ions are then copper and CO3, carbonate. Copper is a transition metal, so we need to figure out that charge. Because that 2 there is a +2 up here. Carbonate is a -2, it's a polyatomic ion. The only reason why this 3 came over into the product side is because carbonate is a polyatomic ion, and that stays together as a group. Crisscross it and it becomes 1 and 1. So these are our potential products, NaCl and CuCO3. This right here is a list of solubility rules. We want to look for these ions within the rules. For instance, here is chlorine. It is mostly soluble except when it's mixed with silver, mercury, or lead. While here it's mixed with sodium, so this is going to form, it's still going to be soluble, so this is going to still be AQ. Copper carbonate, well here's carbonate, are insoluble, so that means it forms a solid, except with lithium, sodium, potassium, or ammonium. Well, copper is not in that list, so that's going to be our S. And that's where these letters here come from. If they both form AQs, if they are both soluble, then you're just going to simply write no reaction, because that means nothing actually occurred. And from here, make sure you balance it. We have 2 sodiums here, and we have 1 here, so I'm going to put a 2 in front. 1 carbonate, 1 carbonate, 1 copper, 1 copper, 2 chlorines. Because I put that 2 there, the chlorines are now balanced. Let's try that again. The inside ions come together, outside ions come together. Ag is written first over here, so I'm going to write it first here. Ag is now with Cl. Ag is a transition metal, but it's one of those few transition metals that don't actually change. It's always going to be a +1. Cl is a -1. Crisscross it. It's 1 and 1. The inside ions come together. H is with NO3. H is a +1. NO3 is a -1. Crisscross it and becomes 1 and 1. Alright, so we have the balanced compounds now. Now we look at the solubility chart. AgCl. Here's Cl. It forms an aqueous solution unless it's with silver, mercury, or lead. Well, it's with silver here, so that's going to be our solid. HNO3. Here's NO3. It's soluble with no exceptions, so it's going to be AQ. The last step is to make sure that it's balanced. 1 silver, 1 silver, 1 nitrate, 1 nitrate, 1 hydrogen, 1 hydrogen, 1 chlorine, 1 chlorine. It's balanced, and that is your reaction. The inside ions come together, outside ions come together. We have Na is now with NO3. NO3 is a polyatomic ion, which is why that 3 came across. Na is a +1, NO3 is a -1. Crisscross it, becomes 1 and 1. The inside ions is Cu and Cl. Cu is a transition metal, so we have to determine its charge. Here's the 2 from the original compound. If we uncross it, that gives it a +2 here. There's an invisible 1 here, -1. Double check the anion. Nitrate's supposed to be a -1, so that's fine, which means copper is a +2. We didn't have to unreduce it to figure out the charge. Cl is a -1. Look on that, find that on the periodic table. Crisscross, and we have CuCl2. And that's where those little subscripts come from. Now we want to look at the solubility chart. Here's nitrate. It is soluble with no exceptions. So no matter what, it's going to be AQ. Copper chloride. Here's chloride. It has some exceptions with mercury, silver, and lead. Well, we're with copper here. We're not with one of those 3, so that's going to be aqueous as well. It's not an exception, which means that they're both aqueous. So instead of writing on that, I'm going to write no reaction, because that means that there's no reaction that actually occurred. All 4 of those ions are still floating around in solution. Alright, one final example. The inside ions come together, outside ions come together. So that means the lead is now with the sulfate. Once again, that 4 is coming over because of the fact that it's a polyatomic ion and it stays together. Lead is a transition metal, so we need to figure out its charge. Because of this 2 here, this gives lead a +2 when we uncross it. An invisible 1, so that means nitrate's a -1. Double check the anion. Nitrate's supposed to be a -1, so that means I don't have to unreduce it. That means lead is actually a +2 charge. Sulfate's a polyatomic ion, it should be a -2. Crisscross it, and they cancel out. Now let's look at the inside ions. Hydrogen needs to be written first because it's positive. NO3. Hydrogen is a +1. NO3 is a -1. Crisscross it, it turns into 1 and 1. Alright, so from here, let's figure out if we have a solid. Lead and sulfate. Well, here's sulfate. It's soluble except with strontium, barium, lead, and calcium. So lead is one of the exceptions, so that's going to be our solid. HNO3. Here's NO3. It is no exceptions. So that means no matter what, it's going to be aqueous. Now we want to make sure it's balanced. We have one lead, 2 nitrates. We only have one over here, so we're going to multiply this one by 2. 2 hydrogens. Because of that 2 in front, we now have 2 hydrogens. And 1 sulfate. And that's how you do precipitation reactions.